Hi, my name is Nereso Lopez and I'm a senior engineer with HEEDS Global Technical Support Team. In this video, I will show you how we integrate HEEDS with Flownex SE software to discover better designs faster. HEEDS MDO is a design space exploration and optimization software package that provides great value to organizations by accelerating product development and reducing overall cost. It allows a user to automate their design workflow and rapidly make modifications, all in search of an optimal design. It is built upon 4 pillars: process automation, distributed execution, efficient search, and insight and discovery. Flownex Simulation Environment SE delivers simulation software that enables you to study how flow and heat transfer systems will behave in the real world, where fluid is the driving factor. Here's a description of the problem that we'll be looking at today. The goal is to minimize the life cycle cost of a pump by varying the pipe diameter of the system. Let's begin by taking a look at the Flownex SE model and the preparations we made to make automation possible within HEEDS. In this model, we have an inlet and outlet pressure boundary condition, a pump driving the system, and we will be varying the pump diameter to minimize the life cycle cost of the entire system. To make updates to the pipe diameter and track the changes in the life cycle cost, we will make use of the text file link in Flownex. The text file link allows a user to quickly make parameter changes in an input text file. The results can then be exported out into a results text file. We can quickly add parameters that we wish to change by dragging and dropping from a component property section into the input parameters. We can then track results by, again, dragging and dropping the results we're interested in tracking into the output variable. The input and results text files are contained within the project folder of our model. HEEDS can now make changes directly to this text file and track the results. This concludes the preparation of the Flownex model, and we can now save this model and move to the HEEDS GUI and fully automate the process. We are now looking at the HEEDS GUI. To automate any process and explore the design space, we work across the 5 tabs located at the upper left corner of the HEEDS MDO GUI. The first 3 deal with process automation, and the last 2 deal with design space exploration. We begin in the Process tab, where we will make use of the General Analysis portal to launch Flownex SE. With the General Analysis portal, we need to define the execution command to launch our tool. In this case, we've taken advantage of Flownex's Python API to create a script to launch our analysis. This Python script defines the project file name, obtains the current working directory and project path, launches Flownex SE or detects if an instance is already open, then solves a steady state solution. And in that solution, any new input values are read and the results are written to the results text file. On the Files tab, we'll add our input text file and our Python script on the input file side, and then we'll add our results text file on the output file side. We can then move to the Parameters tab. In the Parameters tab, we define any variables and responses that we wish for HEEDS to update and track. And in this case, we set the diameter variable from 0.1 to 1. We also create a text variable for our project file name. For responses, we create the LCC response that we wish to tag in our output file. We then move to the Tagging tab. And in the Tagging tab, we are showing HEEDS where the variables and responses are located within our input and output files. On the input side, we are tagging the diameter of the pipe. On the result side, we are tagging the LCC value from our results file. In our Python script, we are tagging the project file name for our simulation. Now HEEDS knows where to make updates to our input files and track the results for our responses. This completes the automation portion of setting up your HEEDS MDO study. We can then define the type of exploration we wish to perform. We begin in our Study tab. We will perform a parameter optimization. We will treat all the objectives equally, and we will run 20 evaluations. Our goal is to minimize the LCC value, or the lifecycle cost. We have completed the settings for the Study tab. We can move to the Run tab and run our study. In this example, we've already completed 20 designs. We can directly post-process the data by opening up HEEDS Post. We begin at the design table, and we see that HEEDS has collected all the inputs and responses from all our designs. We can sort this data and find our best performing design. In this example, a diameter 0.174 has the lowest value of LCC for the system. We can then plot this information on a 2D relation plot. And here we see the influence of pipe diameter on the LCC of the system. The best performing diameter of 0.174 is located within the valley of this curve, shown here in the yellow dot. In this video, I've shown you how easy it is to use HEEDS to automate your existing Flownex models. This workflow could be saved to a template and shared with other users. Additional tools could be coupled with Flownex if needed. Once automated, optimization then allows you to get more insight and make faster product design decisions with more information on hand quicker. Thank you for your time. My name is Ernesto Lopez. Have a great day.